AI workshop. I'm really excited to have you all here. So, in the next 2 hours, we are going to discuss deeply on what generative AI is, how it evolved, and why it is such a big deal, right? And how can you be the part of AI revolution? Okay, so stay engaged. From my side, I can assure you that it's not going to be a boring session. So I'll keep it more interactive, right? Okay, so you should unmute yourself and answer to whatever the questions I ask, or at least be a part of it in a very interactive manner. Okay, yeah. So this is our today's agenda. We'll begin with a quick look at the evolution of artificial intelligence, then how um, it led to generative AI. Okay, so from artificial intelligence, how the machine algorithms or the concepts evolved to the generative AI. So that part we are going to cover in depth, and then we'll be seeing the historical evolution just for 5 to 10 minutes. Okay, so it won't be more. And then the most important part of all everything is this demystifying generative AI. Okay, so this is the main part which we are going to cover today, and then we'll be looking at the career insights and job opportunities, and also the future trends and industry impact. Okay, so our main concentration will be on demystifying the generative AI, or explaining in detail of what generative AI and how it is evolving with time. Okay, we'll also see the major milestones of artificial intelligence, etc., etc. Okay, so it is going to be interesting, right? So yeah, let's move to the next slide. Okay, firstly, I would like to ask, what is artificial intelligence? Okay, many of you are already listening about this particular term from a very long time. Okay, this is not a new one. If generative AI is there, then yeah, yes, it is a new thing which has come up from the past 2 years. Okay, but artificial intelligence has been from a very long time. So I would like to ask you, what is the meaning of artificial intelligence? Okay, so if someone wants to unmute and just tell me the quick definition of what this artificial intelligence, a brief one would be fine, or otherwise, okay, you can also chat in the chat box, right? Yeah, I have given it here. So, artificial intelligence is when machines think and act like humans, okay, and it can learn, solve problems, and make decisions. So, these are the two important things of artificial intelligence, and I have kept it in a very minute way. Okay, this is a very simple way of defining the artificial intelligence. If someone of you do not know what artificial intelligence is, these two are self-explanatory, right? And then we look at the broader spectrum of artificial intelligence. Okay, so I believe none of you have in-depth knowledge of artificial intelligence. Okay, because many people, even though they are working in machine learning or the present generative AI, they won't be knowing the broader spectrum of how each of the subfield work. Okay, how these are dependent with each other, and how these are independent with each other. Okay, so these are the things we must know. So, artificial intelligence, as I said, is a broad idea of making machines smart, like thinking, solving problems, or understanding language, whatever it is, it is all part of artificial intelligence. Okay, so this we have already discussed. And what is this machine learning? Machine learning jobs have been, in a tremendous quantity, right? So from the couple of years, probably from have to know what this machine learning is. Machine learning is a part of artificial intelligence. You already know about it by looking at this picture itself, where machines will learn patterns from data that we provide and make decisions without being directly programmed. Okay, so this is nothing but machine. Whenever we give data to an algorithm, okay, whatever the algorithm it may be, machine learning contains lots of algorithms, and when you give a data, specific data to it, it will learn patterns from it and it can do tasks from that particular data. Okay, so that is nothing but your machine learning. So you're making the machine to learn from the data you provide. So that's all. And then coming to deep learning. Okay, so deep learning, as you can see, is a part of machine learning. And there is an interesting thing about deep learning. Okay, so this is the point where we, our researchers or scientists, have decided whether a machine can think like a human. Okay, so however our brain is working inside, right? So our brain process lots of things, right? In the same way, can we create a machine? Okay, that was the first thought they got. And then they introduced this concept. Okay, we'll go in detail what this deep learning is, because it is very much connected to generative AI. So we'll have a in-depth knowledge on what generative AI, at least to the definition level. All right, and then what is this generative AI? So this entire workshop is on generative AI. We'll have a very good information on this generative AI in the coming slides. Okay, but for now you already know about it, because we are already using many generative AI applications. Okay, whether it may be chatbots or virtual assistants or whatever. So we are already using this generative AI. So we know a little bit of information about it. Okay. Okay. Let me move to the next slide. So this is the question we have, right? What is generative AI? Okay, if I ask you what are the applications of generative AI, you might say generative AI is a branch of artificial intelligence which can create new content like text. Okay, because we are using this regularly in our day to day life, whether you are a software engineer or healthcare specialist or whoever you may be, but you are using this particular application for generating text. Okay, and we the Ghibli has come in chat gpt, it was introduced right recently, and people have started using Ghibli, Dali, etc., etc. So you know that generative AI can create a content like text or images, but it can also create some part of videos, and also unstructured data as well. Okay, sorry. Yeah, so these are the main applications that we know, but the applications are not at all limited to this. Okay, generative AI is penetrating into almost all of the industries. Okay, for example, if you see it here, biological data sequences. Okay, the medical studies like drug discovery, or the studies of x-ray or MRIs or CT scans. So all these are now have become or dependent on generative AI. Okay, and then 3D models, and then structured data like tabular or charts. So generative AI is being introduced into each and every application to make the tasks easier. Okay, so if you're thinking that generative AI is all about creating these four, no, generative AI is entering into almost all of the industries. Okay, so that thing we have to keep in mind. And now, so I have told you these four applications. Then what this workshop is all for, right? In this workshop, we'll specifically cover on text related applications of generative AI. Okay, why? Because the current generative AI trends, if you see, most of the jobs or most of the applications that we are using in our day-to-day life are completely text. Okay, whether it might be chatbot or virtual assistants like Alexa, Siri, Cortana. So all these AI voiceover tools, so all these are will be coming under sequence modeling, and it will be part of text, and we'll be in-depth covering on this text part. Okay, because if you can understand this, you can correlate the same concepts for this as well. Okay, now So what are the things that we are going to discuss today? Okay, or what are the key text based applications of generative AI? Okay, so text based applications means you already know chatbots, virtual assistants, and chat gpt. We are using chat gpt, claude, gemini, etc. will be coming under this domain. And a text summarization, so by the word itself you must say it is nothing but summarizing your large text. Okay, for example, we are using in shots, way to sms or daily hunt, right, in our day to day life. So which provides the entire text in a summarized manner, the news articles I'm saying, right? So this will be coming under text summarization. And then sentiment analysis and tone detection. Okay, so sentiment analysis means, so every day or weekly once we are using this book my show for providing any review of the movie that we watched recently. Okay, so there we'll be either providing the comment or the rating, or only one. Okay, or not only in book my show, but we have this particular applications in many of the other websites as well, in e-commerce websites, or for the dresses that you take. So you will be providing some reviews to it, right, on the scale of 1 to 5. So 5 being the best and 1 being the least a review that you are going to give. So sometimes we give only text but not the rating. So this sentiment analysis, the machine will be able to read over your text, and it judges whether you have a positive review on that particular product or not. Okay, so that is a one type of sentiment analysis. Of course there are many, but it is one of them. Hope you understood what is sentiment analysis. And content generation, you already know, right? And language translation, so this we have been using, right? So whenever we move to some other state where we don't know their language, then we are immediately opening the Google Lens over there or Google Translate. So it comes under the language translation, and it will be part of your text based application itself. Okay, and then personalized recommendations, right, in Hotstar, Flipkart, or Amazon India. We basically see a product and we show interest on it, right? We add them in wish list. Okay, so all those things, and code generation, which you already know, and knowledge management and QA systems, which we will discuss in the coming slides. Okay, and text based games and interactive storytelling. So these are all the applications of generative AI. Please don't think that generative AI is limited to chatbots and virtual assistants in terms of the text based applications. Okay, its advantages or applications are vast. Of course, the list is not ending. Okay, I kept only the main ones that we are going through each and every day, right? So before we delve into generative AI, I would like to show you some of the milestones of artificial intelligence. Okay, so it all started in 1950. Okay, I'm not going to give you what happened at that time. Okay, but these are the major milestones. 1956 artificial intelligence term was coined. 1967 ELIZA, so people came to know. So 1967 people do not know how to type in a keyboard itself, right? But then that time itself they created an algorithm. Okay, so this particular algorithm, whenever you ask it how are you, it will be responding like I am fine, how are you. So that is the only thing it does. Its capabilities are not equivalent to the llms that we have today, right? So this elisa is something, that algorithm, which impressed the people. They thought a machine can converse like a human. Okay, so they were greatly impressed by its capability. So they thought only humans can talk to humans in a language that each one of them interacting will understand together, but a machine could do the same. So that was the time 1967. And 1980 expert systems, recurrent neural networks. From here we'll be having a in-depth understanding, you need not to worry. And then, so 1977 LSTM. Okay, what is RNN and LSTM? We'll discuss. And 2012 deep learning emerged, and then 2017, 2018, we'll have a detailed understanding on this. But I would like to point out one specific milestone at this point. Okay, 2016 it was. It was a time when deep learning was already introduced, and many of the neural networks. Okay, at this point you may not understand what is neural network, but please remember deep learning has introduced terms like neural networks. So based on those neural networks, we were able to create text related data, or image related data using the computer vision, etc., etc. But whatever I'm saying over here is happened on 2016, where an algorithm called as AlphaGo, which was introduced by Google. Okay, it defeated the world champion in the game of Go. Okay, so this was quite impressive, right? So a machine or algorithm defeated a world champion in a game. That too, it's not a normal game, it is a Go game. So if you don't know what Go game is, it is quite similar to chess. Okay, so chess will be having thousands of permutations and combinations to make a move, right? In the same way, Go will be having a lot more than that. Okay, and in that particular game, an algorithm called Go defeated that world champion. So it's an outstanding a milestone of artificial intelligence, right? Yeah, and then 2017 Transformers, 2018, you already know, Chat GPT, Dolly, everything has come up. Don't think that I am going little faster, because these are a generic data. Okay, so you can have this information in Google itself, so that's the reason I'm going fast. But when it comes to the concepts, I'll be going very slow until you understand it. Okay. Yeah. And coming to your types of artificial intelligence, so we know what is artificial intelligence, but we do not know what are the types available in artificial intelligence. Okay, so I have provided you the types, but it is in one point of view. However, you will have lots of other types of artificial intelligence. All right. So firstly, rule based AI has come up. So those are the sequence models itself, which will generate the text. Okay, but how they creates the text is based on this if and then rules. Okay, so if and else condition we have in Python, right? In the same way, we'll be having this if and then rules, and this rule based AI was dependent on that. And then machine learning, it is we have lots of jobs, and around 4 lakh people in India are working as machine learning engineers, or somewhat related to machine learning or data science, right? So machine learning is I have already introduced about it. So machine learning has come up after a later point of time, and it has its specific usage. Okay, we'll discuss about it very deeply. And the other type of artificial intelligence we have is deep learning, which came up in 2016 2012, I guess 2012. And it introduced neural networks concepts to us. Okay, and then generative AI, which we have been seeing from 2018. Okay, maybe people may not be knowing that generative AI existed in 2018, but yes, it was. Okay. Yeah. And then so we'll be discussing topics in a sequential manner. So it is like a historical point of view. So over the years what happened, so like that we'll be covering this workshop. Okay, so then only you will get a very good understanding on this AI evolution. Okay. Yeah. Then we have entered into machine learning era. Okay, what is this machine learning? When AI started learning from data. So that is the simple definition of machine learning. Okay, so machine learning is when machines learn patterns from data without being explicitly programmed. Okay, so you need not to worry about these definitions. When we look at the applications, you can understand this machine learning concept. Okay, and it's about training a model instead of writing rules. And the more data you give, the better the model becomes. Okay, so what are we saying here? Okay, so we have already discussed the definition of machine learning, right? Machine learning is nothing but a field of artificial intelligence where a machine can understand, get the data from humans, and then learn the patterns in the data and perform the tasks based on the data. So that is nothing but your machine learning. Okay, when we look at that application, so this is what I kept a simple image. This machine is learning from the data. Okay, afterwards, once it learns from the data, it will go and do its task. Okay, this is a simple way I have kept about this machine learning. Yeah. When coming to the applications of machine learning, you will understand whether we are using it in our day-to-day life or not. Okay. So for example, you are using this Gmail. Whenever you get an email, so it will be automatically loaded into the specific folder, right? So it may be your inbox, or it might be the spam, or if it is a advertisement, it will be either social or promotions, etc., etc., right? So behind this Gmail application, sorry, behind this Gmail application, we have a machine learning algorithm which is sorting your emails based on the type. Okay, so it is also dependent on machine learning. And then Flipkart recommendations. This is a simple. Of course, in other e-commerce websites also, you get recommendations, right? Not only in e-commerce things, also in YouTube, you will be getting recommended videos, right, based on your past behavior. So all those recommendations are part of your machine learning algorithms. And even Google Maps we have, okay, which predicts the traffic. Okay, so this is also part of your machine learning. And the applications are not limited to only these three. We used to have the customer service chatbots, right? For example, if you open the IRCTC, we had some chatbot. Now also we have some chatbots, and not only in IRCTC, but also in many public platforms, or even the private company related platforms, we have specific chatbots. And even before generative AI was creating revolution, these chatbots were in use. Okay, how did we create those chatbots? Are by using the machine learning algorithm. Okay, and also we have this stock market predictions, smart home devices, um, right? And also, in if you open no broker, you'll be saying based on the number of rooms, or based on the size of the room, it will be predicting the house rent, right? All those are part of your machine learning itself. All right. Yeah. So till this point of time, in time, right, specifically in time, the machines were learning from the data. So this is nothing but your machine learning. Okay, and we went to this particular concept, to human like learning. Okay, so till this machine learning time, we used to have chatbots. Okay, but usage of that sequence models or text generation was not up to the mark. Okay, it created revolution in the text related data, but it is not up to the mark. Okay, then we introduced, our researchers introduced this concept, human like learning, with the emergence of deep learning. Okay, till this point of time, machines were learning from data that we provide, and then learns patterns from the data and perform the task, like house rent prediction, etc., etc. But it was limited, its capability is limited. From here onwards, machines started to behave like humans. Okay, it started to behave like the human brain processing. Okay, so that is nothing but your deep learning. All right. Yeah. So, if you are going to attend for any generative AI interview, or if you are going to start your generative AI syllabus, you must understand the concepts from deep learning. Okay, so your generative AI concepts starts with the in-depth study of deep learning, and then natural language processing. Okay, then RNNs, LSTMs, transformers, LLMs, RAG, LangChain, prompt engineering, fine tuning, etc., etc., etc. This is the sequence that we follow. Okay, even when you start your generative AI preparation, you must be following this particular way. So deep learning. Coming to deep learning, what is deep learning? Deep learning is nothing but teaching machines to think like the human brain. Okay, so here I have kept our human brain nerve cell processing, and on the right side, I kept something which you do not know at this point. okay, but you will understand it in a couple of minutes. So deep learning, coming to the definition, is a subset of machine learning and artificial intelligence, which you already know, that uses multi-layered neural networks. Okay, so it is inspired by the structure and functioning of human brain. Okay, this is the point which you have to consider the most in this entire definition, inspired by the structure and functioning of the human brain. So what is this human brain structure and why it is inspired? Okay, so for example, I am talking to you, right? So for generating the text, my brain is already doing lots of processing inside. Am I correct or wrong? Right, so my brain is already doing lots of processing inside. And if you know this, our brain contains billions of nerve cells or neurons we call, and this is a single nerve cell that I have kept. And if you can understand how our brain process things, you can understand the deep learning concept. Okay, because it is inspired by that, right? So this is a single nerve cell. Okay, and dendrites are the inputs. So for example, a pain sensation or text generation that I'm doing right now, so dendrites will receive the inputs. Okay, this will receive the input, and cell body over here, it will process that input, and then synaptic terminals, you know, these will provide the output to the other nerve cell. Okay, so this is input, this is processing, and this is your output providing layer. So in the same way, researchers, when they thought we would like to introduce a concept where these algorithms will work just like human brain, they wanted to replicate in the same manner. Okay, so here it is the input layer and hidden layer and the output layer. So input layer receives the inputs just like dendrites, and hidden layer will be processing the input. Okay, it will be doing the certain calculations. So it is nothing but your cell body here and hidden layer over here, and the output layer, it provides the output. Okay, so this is, if you call this as a natural neural network, because the neural nerve cells are connected with each other, right? So it can be called as natural neural network, and we are creating some network inspired by the same. So we are calling it as artificial neural network. If you have understood this concept, okay, so we have already covered some 25 to 30% of deep learning syllabus. Okay, yeah, just a second please, I'm having sip of water. So hope you understood that, right? Deep learning, you got that idea, it is inspired by the structure and functioning of the human brain. Okay, yeah, let's move to the deep learning, how it is categorized. Okay, so we have two types of main data, image data and a text data, right? So coming to the image data, deep learning have the CNNs or convolutional neural networks. Okay, this is also neural network. And for the text data as well, we have a certain type of neural networks, which are RNN, LSTM, and transformers. Okay, from here onwards we will be discussing all these things in detail, and of course these are the concepts that you must learn as part of your generative AI syllabus. So since this is a 2-hour workshop, I'll give you a brief understanding of what concept this is, and understanding of the concept, and how it advances to the future topics. Okay, yeah. Okay, this is text related. So deep learning, different problems require different types of solutions, right? And deep learning has provided the same. So if you are dealing with image data, it has provided the convolutional neural networks. And if it is a text data, it has provided you RNN, LSTM, and transformers. Okay, yeah. And from here, we will be having a detailed understanding, because it is actually required for you. So this is RNN, which we have seen right here. Text related deep learning data type. For this text related data type, we are going to use this neural network. Let us see how RNNs were used to work. Okay, so RNNs came in 1980s. Okay, so it came in 1980s, and it was used to generate the sequential data like text. Okay, so we'll have a good understanding how RNN used to work over here. Okay, so it is first, for now it is nothing but a type of neural network. It is called as a recurrent neural network, and it is type of neural network designed for text related, which you have seen in the previous slide. So let us see how this if I make a chatbot, when people used in 1980s, if they make a chatbot, how it used to create a reply. Okay, so here I'm introducing myself. This is Naveen. I'm from Hyderabad, and the climate here is warm and during summer here. Okay, it replied, "Hello, how can I help you today?" So then I am working on comparing different neural network models. So it said, "That sounds interesting. What specific models are you comparing?" Okay, it replied well, right? And then, "Can you remind me what my name is and which city I'm from?" So I got a doubt whether it remembered my name and a city, right? So I asked it, and it said, "I'm sorry, I don't remember your name or city." Then I asked it, "What did I mention about the climate?" It answered, "I don't recall you mentioning anything about climate." Hope you understood how RNN used to work. So the main problem of using RNN was memory retention. Okay, the main problem or the biggest limitation of RNN is nothing but they forget. Okay, they forget, because it forget my name and it forget my city, right? So that is the biggest limitation of RNN. So let me take out the notepad and I'll explain you what this RNN is all about. Okay, RNN. Okay. So what used to happen in RNN is word to word processing. So, for example, I told it right. This is Naveen, and I'm from Hyderabad. The climate is warm over here during the summer, right? So when I said that, it used to process the word by word. Okay, this at once, Naveen at once, okay, and climate at once, Hyderabad at once. It used to process words word by word. So process data in a sequence, one word at a time. Okay, it means one word at a time. So this is how it used to process the data, and the biggest limitation of it is simply it remembers recent words but struggles with long term dependencies. So am I right or wrong? Can someone say if you understood the RNN? So are these the main points that we discussed so far? Can someone unmute yourself and reply to this? Hello. You can unmute yourself, and or even you can type in the chat bot, this chat box itself. Is everyone following me? Has anyone got any doubt, or is it boring, or would you like to provide any feedback at this point of time? Do you want me to go slowly, or can someone just unmute yourself and tell me whether this is what we have discussed and what this is the limitation RNN is facing or not? That's it. Please unmute. Okay, at least you can hear my voice, right?
Yes, no, I agree.
Okay, fine. Hope you are following, guys, because
Yes.
yeah. Thank you, Vinod, for the confirmation. So yeah, at least you tell me that whether this is what we discussed so far, coming to RNN concept or not.
Yeah, correct.
Yeah, thank you. Thanks for the confirmation. So, guys, rest of you, I hope you are following it. Okay, no problem. If you want me to go a little bit slow, I can. Okay, so this is nothing but your chatbots, I mean, the sequential data creation. Okay, so how the chatbots are creating the sequence, word sequence, text sequence. This is nothing but a sentence, right? And it is also sequence of words, right? So how this a machine is able to create this text in a sequential manner. Okay, so that particular application is what we are discussing, and RNN is the first one that we have started discussing on. Okay, now, so this is the thing I explained you, the limitation of RNN being it struggled with long range context. Why? Because when I say the climate is my name, Hyderabad, and when I said during summer here, it forget everything, right? After few messages it forget this particular information. This is nothing but your long range context. Okay, so it is not able to remember what I said earlier. So it is nothing but your long range context, and it used to struggle on this. So that is the representation I have kept over here. So when RNN reads about, let's say, so we have word 1, word 2, we are giving, word 3 we are giving. So this is Naveen, I am from Hyderabad, something like that. Okay, and when it comes to Hyderabad, it forget my name Naveen. So it remember only 30% of it memory retention. Okay, but Hyderabad at this point it would be having 100%. And as we go further, the memory retention on the previous words will be decreasing exponentially. Am I right or wrong? So this is the biggest limitation of RNN. Okay, hope you understood. So what happened then? So RNNs were not performing well. Then our researchers have introduced one more neural network. Okay, and it is also a type of recurrent neural network. It is nothing but your LSTM. Okay, so LSTM is a special type of recurrent neural network designed to remember long-term dependencies and solve this vanishing gradient problem that standard RNNs struggle with. Okay, so you just ignore this vanishing gradient, because when you learn the deep learning concept, I'll be explaining this vanishing gradient in a very detailed way. Okay, even the RNN that we discussed, we'll spend at least 1.5 hours on that itself in a generative AI course. Okay, but I'm just keeping you the important points and the evolution of the sequential data over here. Okay, yeah, I would like to give you as much detail as the generative AI requires. Okay, and requires, and this is the sequence that we usually follow when we taking up the course. Okay, and as I said, I'm a generative AI trainer, and I'll follow this sequence, especially, even not only myself, almost all of the institutes. Okay, and this is a simulation I have kept. Okay, even if you see the RNN before, if I told only these concepts, like this means, you cannot understand what I am actually saying, right? That is the reason I kept everything in a simplified manner using the simulations. Okay, so LSTM has come up. Let's see. So LSTM, I said, hi, I'm Naveen from Hyderabad. I work with AI. Okay, so it also introduced itself. I told it I am building a tool that works in English, Telugu, Hindi, Tamil, Japanese, and Chinese. Okay, so it said that's impressive. What kind of tool are you building? Okay, that's a nice reply from it. I said it's a text sentiment analysis system. My manager wants it also identify product features in reviews. Okay, Then it's replied, sentiment analysis for combined with feature extraction is usual. What models are you considering? Then what I did, I interacted with it around 5 hours. Okay, I chatted with it for 5 hours, and then I asked it, where am I from? It said you are from Hyderabad. It is absolutely correct. And I asked it again, which language did I mention my tool supports? It said, you mentioned multiple languages, but I don't recall with specific ones. Okay, here again this LSTM failed. And then what extra feature did my manager request? It said, I am not sure about the specific feature your manager requested. Okay, but for 5 hours it was able to remember everything, but after a prolonged usage it forget the information, right? Now let me tell you how this LSTM work. Okay, so this is LSTM, the concept, and you know what it has done? It retained the important information, like it successfully said my name is Naveen, and also it said I'm from Hyderabad, right? It remembers that important information over long sequences even after 5 hours of my prolonged usage with it. Okay, and then you know it uses some gates inside. Okay, it will have some forget gate, etc, etc. It forgets some unimportant information, and it remembers only the important information. So it is better than RNN, because it is not able to, RNN did not even say my name or where I'm from, even after a very short usage, right? But it is better than RNN. But there is a limitation for this as well, because the memory retention is not up to the mark. Retention is not up to the mark. Am I correct or wrong? And also, computationally, it is expensive than RNN. So these are the limitations we have. Okay. So our AI industry took a break at this point, because even though they introduced two models, RNN and LSTM, LSTM was successful in some way. Okay, it is able to remember some important information, and it is better than RNN. But of course, there is one more thing, memory retention is again coming up as a problem. So there was a huge break at that particular point of time. Okay, now let's see how LSTM has this memory retention over long sequences. Okay, so this is the memory retention of LSTM, and it is better than RNN. Am I correct or wrong? Because RNN, the first word went till 20% or 30% when we reach the 10th word, right? But here the first word has around 70%. It is far better than RNN. Okay, so this is the main points of LSTM. All right. Yeah. Now I was saying, right, in the AI industry or in the IT industry, there was a break. Why there is a pause? Because we were creating chatbots, translations, voice assistants using RNNs and LSTMs till 2017, and it was good. Okay, but not up to the level, and the limitations were quite common. Long test, it wasn't able to process. The training was slow because word by word processing was happening. Memory fades over time even with LSTM. Am I correct or wrong? Memory fading problem is not only limited to RNN. It has come up with LSTM as well. And yeah, this has become a biggest limitation and harder to scale for larger data sets. So these are the limitations we have. And at that particular point of time, industry hit a plateau, which means you know there was a huge break. Progress was steady, but it was not revolutionary, right? There were creation of chatbots, translations, and voice assistants at that time as well. But It was not revolutionary. At this point of time, you know, AI needed something faster, smarter, and scalable. So this was our requirement, right? So what happened then is a story, right? So we are going in a sequential manner, right? So it was till 2017 only. Then what happened in 2017 is the question. So the pause which happened till 2017 is before the explosion, okay? And what happened after 2017? So transformers was introduced. Whatever the LLMs that you are using in your day-to-day life, chat gpt, claude, gemini, or llama, etc., almost all of the LLMs are dependent on this transformers mechanism. Okay, this is that important. So in 2017, people have introduced this particular research journal. Attention is all you need. Okay, it was introduced by one of our Indians itself, and this set of people are from Google. Okay, so from Google, they introduced this particular research journal, so which indirectly introduced this transformers to us. Okay, this revolutionized like anything, and this is the beginning of your chatbots or any text related data or any image related data. Okay, so you are using Ghibli, right, in chat gpt. There we are creating an image, but it is also dependent on transformers. Okay, yeah. So in my class, we will have a thorough understanding on each and every topic for for 2 hours or 3 hours. Particularly these transformers, I to my students, I explain this for 3 hours the concept, and then I'll show this self attention mechanism which is behind this transformers. Okay, there I'll explain a math problem how the self attention mechanism is processing the words, etc., etc. So by that way, I'll be leading out the class. But for here, actually do. Okay. So till now we had these problems, right? Word to word processing and limitations like long term, dependencies was a problem, right? In order to avoid all these, transformers has come, and what it did, it performed the parallel processing. Okay, so earlier we used to have word to word, right? But here all words are processed at once. So which means the training is faster. Am I correct or wrong? So the training becomes faster in this way. And also, you know, it handled wrong long range context far better than LSTM. Okay, these are the main uh, you know activities performed by your transformer, and it changed the way we look at the text sequential models. Okay, like RNN and LSTM, whatever we have, transformers has changed our way in looking at the future. Okay, so the scalability. Also there is one more thing, right? Scalability. So scalability means, so these can be trained on billions of words and still perform exceptionally well. It can be trained on billions of words. Also, it performs exceptionally well. So these are the main advantages of transformers and the self-attention mechanism behind them. Okay, as I said earlier, transformers work on self attention mechanism. All right. Yeah. So now we have understood these transformers. So if you remember that the differences between three, RNN and LSTM were processing word by one, word by word, right? But transformer sees entire sequence. Okay, let me give that particularly here because it is important for you. RNN or LSTM, and this is transformer. Okay, so RNNs process word one by one, and transformer, you know, it sees entire sequence at once. All right, and then second one is hard to remember long texts. Am I right? And here uses self attention mechanism, okay, to track everything. And then, slow to learn, because word to word processing is very slow, right? So slow to learn means what you'll have here: parallelized training. Okay, so this was the time we have started using the GPUs. Okay, so the parallel processing is only possible with using GPUs, right? That's a thing I have mentioned over there. Sequence bound, and then works on any position in the input. Okay, yeah, so this happens, this process the words in a sequence. Okay, and uh, and transformers, they work on a position in the input, whatever the position the word may be. Based on its importance, the transformer will be understanding the entire sentence. Okay, so transformers are nothing but they work on giving importance to the words. Okay, if you have a sentence like Naveen from Hyderabad, and working as a generative AI professional, and also working as a generative AI trainer. So this particular information, transformer will be able to know to what words it has to give more importance. Okay, so that is nothing but your fourth point. Hope you understood the differences between RNN and LSTM. Okay, now let's move forward. So yeah, by looking at that itself, when I said transformers are the backbone of all your large language models that you are using today, you must have understood that it is the game changer. Am I right or wrong? Yes. So we'll see why it was a game changer. We have already seen, but the state of the art transformer models we have, right? The GPT-4, GPT-3, Gemini 1.5, which is introduced by Google, Mistral, Llama, etc., etc. State of the art models are nothing but well recognized and well used models. Okay, the models that we are using today are these, and all of these are dependent and works on the mechanism of transformer. Hope you got this single point. So whatever I said now is important. All right. Yeah. Hope you got that. Now moving forward, this is just an evolution of language models. Okay. Just have a look at it. I'll take a sip of water. Yes. So you understood that transformers have come up in 2017, and companies have started building large language models using these transformers. And 2018 itself, you can see OpenAI has come up with GPT, and BERT was introduced by Google. GPT, first they introduced GPT-1, then GPT-2, and GPT 3.5, which the chat GPT worked on GPT 3.5, right? So it was having around 175 billion parameters. And then Google has came up with a smaller model like BERT with 340 million parameters. Okay, so 2018 these LLMs were introduced, and 2022, chat GPT has entered industry. And if you don't know this fact, within 5 days of chat GPT's entrance into IT industry or into the world, around 1 million users started using ChatGPT, and this is the only application has that much demand. Within 5 days, 1 million users is not a small thing, right? And it created that history. So even you would have used ChatGPT in 2022 November, December that time, but people started using more from 2023 April. Okay, and 2023, as you know, many other models, multi models have come up. Okay, Llama by Meta, Palm 2 by Google, etc., etc. Yes, and this is a major milestones of artificial intelligence which we have already seen. So I'm skipping this part over here. So yeah, this comes the question: what is a large language model, right? So can someone unmute yourself and answer me what is this large language model? Just tell me the definition. That would be enough. Can you hear me? So at least you can chat in the send an message in the chat box. What is LLM? Okay, or otherwise should I pick someone? Okay, fine. Don't worry. I'm going to give you the concept clearly. I'll write it over here. Okay. What is LLM? This is a basic question. So LLM is nothing but a large language model. Okay. So why it was called large? That points also we need to discuss, right? Why large?